Hello and welcome to another chilly November day. Hopefully you're nice and warm wherever you are. Thank you very much for joining me. This is me, John Stevenson, with Practicalli. And so today we're going to continue with another little exercise from exorcism.io, which is a really good way to practice and learn Clojure. And we are going to use the series challenge, which is fairly simple, I think, although it did take me a little while to make the code as nice as I wanted it to be. I do sometimes kind of think that if the code's not elegant, then I could try harder. Obviously, sometimes you need to get things done, but it is nice to revisit some code and think, well, can I do that differently? Which is the whole point around doing katas. And you should be, I encourage you to, if you are doing the exorcism challenges or even the foreclosure challenges or any coding challenges, is to do them more than once and see if you can find different ways to solve them, because it's a great way to actually learn. Right, quick plug. Ooh, let's go to there we go. Practicalli. So I wrapped up the Clojure Together sponsorship, although I've applied for next quarter, so maybe I'll get that. Fingers crossed. If you're Clojure Together, then I'd appreciate any vote for me. There's lots and lots and lots of work to do. As you can see with all the books, they've got several hundred content and ideas already, and I've already started doing a little bit of work for the data science stuff as well. I've got 46 content ideas to build for that. Also doing some documentation around remote collaborative development. So we actually have a look. We did this yesterday. So we basically created a shared server, installed Clojure, set up an SSH connection, and then started a REPL on the remote server using the Cider and nREPL middleware, and then there's kind of configurations to use that. So we got Emacs and NeoVim working. We also got Visual Studio Code working for that as well. And it worked pretty well, actually. So just having a shared server where everybody can connect to it was really good fun, and it was very easy for us to collaborate on it. Obviously, we need to take turns in saving the files, but that wasn't an issue. I think it's trying to get people familiar with the new environment. Just takes a little bit of time, but that worked well in the end. Yeah, we had good fun doing that, so it's quite easy. And we even set up a reverse proxy on there as well, so we could do some data science journals and show some graphs and so on, so anybody could actually go onto the web address and look at the journals that we were creating as well. So that was good fun. So there'll be more of that coming over the next few months as well. And if you want to reach out or got any suggestions, then Zulip, Clojurians, or Discord are all, you can all reach me via those channels, whichever you prefer. I'm usually on Zulip most of the time these days, and it keeps all the history, so it's quite nice. Morning, Chris. And if you want to support me, then obviously subscribing to my YouTube channel. I'd like to get up to 1,000 by Christmas, but that might be pushing it a bit. We're up to about 860, I think. And if you are working commercially and benefiting from what I'm doing, then obviously I appreciate any kind of a GitHub sponsor or direct sponsorship. That'd be just help keep the wolves from my door. Okay, let's get on with the meat of this, or the tofu of this, because I'm vegan. So exorcism. So hopefully you've seen some of the previous videos that we've been doing with exorcism. So working on the Clojure track. I might have a go at the Emacs Lisp one over Christmas. And I actually I'll put this back into mentorship mode. So if you're actually you can use exorcism in mentorship mode, and it gives you a very guided path in how to tackle the challenges, but it also gives you a few extras as well. So even if you're doing the mentored path, then you can jump into series and do this one as well. Oh, there's the answer. Oh, did you see it? We'll come to that in a moment. I sometimes do submit answers for mentors as well, just to get their feedback as well. Oh, I'm showing you the answer again. So there's a few different ways I've done this, and I think this is mostly about refactoring the way I've done this, but we'll walk through it day by day, step by step. So the challenge itself is, I think it's fairly clear. So we're given a string of digits, and we need to output all the contiguous substrings. So basically, where of a length n. So we're basically like just dividing up the string into specific lengths, and we're given the length as well. So if we've got this number, then we get 3. So we've got this sequence, then we've got 3 other sequences. So we're basically taking a sequence, splitting it up, and generating all the possible sequences from that. And there is some scope to this, so that if we're doing larger strings, then it's not offering any guarantees as to what we're going to get. That's a rather blunt description. And if we actually look at the project EULA one, I think this is a bit more involved, because basically you've got this 100-digit number, and we want to find the greatest product. So that could be kind of an extension to this, but I haven't actually covered that this time, but it might be another interesting exercise to do. Oh, we're getting busy today. About 12 people. If you've got any questions, feel free to ask them in the YouTube chat. I will be watching out for that. Okay, so let's get on with the coding. So I'm using Spacemacs. I will be pushing out a video. I probably won't do a live broadcast next week because it's there's tons of things happening next week. There's the Clojure conference next week as well. But I will be doing a decent, hopefully high quality video about doing REPL-driven development with Spacemacs. So it gives you an understanding how to get the most out of basically using Cider. So all the things you've seen me do here, I'll kind of explain a little bit more, and you'll see kind of how the basics of how I do REPL-driven development. Let's switch to a layer and switch to the exorcism layer. So this has got all my, oh, there's the answer there. Oops. Let's hide that. There we go. If you've got eidetic memory, then you're already ahead of the game. So this is the design journal I've created just to kind of walk through the evolution of the design. And just got notes on what the problem is. So yeah, we've had a look at the EULA problem, and it is kind of interesting, but we've got the, yes, cool. Yeah, that'll be coming hopefully Sunday or Monday. It takes a while to edit those things. So we've got our test data. If we look at the test code, we've got a test series, then we got a series of def tests. So it's normal Clojure test testing that we're doing. And we've got each test has just got one assertion. So we've got a call to slices with a string and with a number. So the number represents the how big the sequence is that we want to generate. So 1, that's fairly straightforward, but we've got an empty string, so that might be interesting. 1, 2, 3 with a sequence of 0, so that's also weird. So if we got 1 but with an empty string, then we're returning an empty vector. So basically returning nothing, I guess, because they're all kind of returning it into a collection as well. Oh yeah, and this one's using a set because it wants to make sure that kind of it's only returning these three numbers, or these three sequences. And so if we've got a slice, if we're slicing up by 0, then we're not going to get anything. If we slice too many, then we're not going to get anything. Oh, well, we get a string if we just slice it up by 0, so we don't take any of the elements in there. And if we've got 3, so we've only got 2 like positive tests, and the rest are all kind of negative tests, kind of catch-all tests. So that makes it interesting. That's still not working. That's weird. Yes, for some reason it doesn't want to select these. It doesn't want to remember it's got these files open. I don't know why. It's very bizarre. Let's get to the design journal. Okay, so let's see. So we've got a string. How do we divide that up? That's fairly simple. I've used partition quite a lot in these examples. It is one of my favorite functions from the Clojure core. Am I not running? I'm not running my REPL. Let's run my REPL. There we go. So we're using Clojure CLI tools for this. Oh, and we're running. Yeah. No. So what I did was just add to series. I've just added this deps.edn file just with source, and I've cheekily put in tests because that way it's going to allow Cider test runner to find the test code, so I don't have to add any aliases or anything to that. Just makes it simple. Obviously I wouldn't do this if I was shipping this code as a jar file, because it would include all the test code. But it's still it's a convenient way to use the exorcism one with Clojure CLI tools. I just find that a little bit faster to start up than lining in. Let's go back to there. I'm sorry, I have to keep opening the files for some reason. This directory keeps getting closed by Emacs. It just doesn't like the files. There we go. Fun, fun, fun. So we've got the REPL running. And so if we can evaluate this expression. Excuse me. So hopefully you can follow along what this is doing. So we're generating a range of 20 numbers, because that's the easiest thing to generate. And so it's generating numbers between 0 and 19. So that's 20 numbers. And then we're asking that we're saying we want to partition that by 5. So it's creating from that sequence of numbers that range generates, we're getting a series of sequence of subsequences. So each of those have 5 numbers in them. So it's pretty easy to partition up and divide up the string. So we can do that. If we've got an odd number, then we can lose some things just using partition. It will only create the partitions if they're complete. So if we want a partition of 6, then it's creating 3, but then it's only got 2 more numbers left. And it can't create a partition of 6 with just 2 elements. So it just throws them away. But if we want them all, then we can use partition all to do that as well. And so this keeps the last partition, but obviously it's going to be smaller. It doesn't try and fill any nils in, but I think you can do padding as well. Let me just check. I'm sure I saw something in padding. Maybe that was something else. Yes. But this way, if you're using partition all, then you can make sure that you're not losing anything, although you do get inconsistent things. So if I was going to map over each of these sequences, then I'd have to be aware that we were using a shorter sequence, so it would actually only do the first two elements of this of each of these sequences as well. So you just need to be aware of what the data is that you're working with. And partition. And so here we're creating a series that so each partition is the same size, and the kind of starting endpoint is defined by the partition size. So we're starting at 6 here because we've done the first 5. But we can also introduce a step. And so, oops. So here we're still generating the same sequence of 20 numbers. And we've got a partition of 4, and instead of being like 5 partitions of 4, we've got a lot more, because each partition is basically starting at the next number. So this one starts at 0, this one starts at 2, 4, 6, 8, 10, and so on. And this is defined by the step value that we're providing. So if we want to go through every single possible sequence from the given kind of collection that we've got, we can just use a partition of 1. And so we get all the numbers. And we can also kind of do all sorts of interesting things by having a different partition and a small step. So we can actually generate quite a lot of different kind of sequences just from using partition. So here we've got a lot of repetition here as well, because we're starting at 0, so we've got 0, 1, 2, 1, 2, 3, 2, 2, 2, 3, 4, and so on. But it's a nice way to generate a kind of like numerical pattern from a simple sequence. And if we've got a if our partition range is bigger than our data set, that's kind of interesting. See what happens there. Oh, we don't get anything there. Okay. Oh yes, because we're using partition, so it can't create a partition of 100 because it doesn't have enough elements. But if we do the same thing with partition all, then it's going to try and create as many as it can. So each partition is there. So it kind of, this is like trying to take everything, but range is only giving it 20, but it'll still take like the first 20 numbers and create a partition with that, and then it starts at 0. So these partitions are getting smaller and smaller and smaller and smaller. So here we get everything, and then here we get one less from the start. So this is kind of almost like iterating through and showing how we'd actually reduce down to a single number, because at the end we get just 19. So there's quite a few nice things you can do with partition. Of course, we can partition a string. So we're taking the test data here. So we take the first test data here, and it's saying take a string and partition it by 0, which is a bit funny, because if we do that, then we just get 3 empty sequences, because we get 0 from the sequence. It's just nothing here. And if we compare that to the vector, then it's saying it's false. And this is mostly because it's not because of the value, it's because of the shape of the data here. So here we've got a sequence, but the sequence is not empty because it's got 3 empty sequences in there. Because if we have we have a vector, and a sequence, a list. Let's just quote that so it treats it as data. Those two are equal because they're equally empty. The values they contain are the same. So Clojure will consider those equal. So these ones are different because the sequence contains values, even though they're empty values. And we could just use the sledgehammer of a function that is called flatten, which just basically just flattens everything regardless. It's a bit of a blunt tool, but it does turn the sequence into a sequence of empty sequences into just a sequence. So if we look at that, if we just look at what flatten does, it's just generating, instead of like a sequence of empty sequences, it's just giving us an empty sequence. And so therefore that will equal the square, the vector that the test is testing for. So this is the result that test data, first test is looking for. So we could use flatten, but I always feel that flatten is kind of the last desperate hope when you haven't thought about how to do it any other way. And it doesn't really, because it doesn't really care about what it's flattening, it'll just flatten it. So if you find yourself using flatten, then put yourself a little to-do on to come back and see if you can refactor it at some point. What have we got here? Yeah, so we can partition. We're partitioning up a string, then it's turning it into individual characters. So we might need to address that. We might need to bring it back into a string. Most of the core functions, most of the functions in Clojure Core will treat a string as a sequence. It's not officially a sequence, but most of the core functions will just treat it as a sequence of characters, which means you often get a result like this. You get characters back in there, and you usually have to, if you want them back as a string, you'll have to join them back together again. We can't seem to quite do the same thing. If we flatten, then we're still getting the just a sequence of the characters, but we still need to pull that back in together and make something nice. I did try a few things, but I didn't quite get what I wanted to do. Map string. This is where we start getting lazy. That wasn't good. So we can't just map string over that. I think we probably could apply string, but we want to do that over the partition, because the partition has, if we look at that, it's a sequence of sequences. So we need to map over each sequence, and then we take each sequence and then we apply string to that, so that it will basically put string in front of all those characters and convert them into a string. Hopefully that made sense. So if we do that, then we get our sequence of 1, 2, 3, which is equivalent to a vector of the string 1, 2, 3. So that would kind of work. And then we could apply that. I seem to have that twice. I don't need it twice. There we go. Boop. So we tried this with the tests. Let's do series. Oh, look, there's the answer. Don't look at the answer. Let's do that. Let's put this into a rich comment block for now. And then just evaluate. So if I evaluate the buffer, then it's only going to evaluate this piece of code and, well, obviously the namespace as well. So evaluate that. Let's go to the tests. And run the tests and see what it does. Oops. And we only get one failure, so that's good. So it's passed all the other tests. but we're getting 1. Which one's it failing? So it's doing the, it says here the number equals 0. So when we're doing this, then it's failing. So it's basically the empty case where we want to just return an empty string as a sequence. That's not quite happening. Oh, that's not the one I wanted, was it? There we go. So we could just go and put an if statement in there and do that. So if the length is 0, we do that. We can also, did I change that? No. Rather than doing an equals 0, there's also 0 as the function, which I think looks a bit nicer. I'm not quite sure which is more idiomatic, but I like this better actually. Yeah. Let's do series again. Let's replace that. Evaluate that. Oops, did I not do that right? Yes, I did not do that right. There we go. And then run the tests. Oh, and that works. So that's where I was kind of pleased that it was working, but I was starting to think, well, can I not make that better? It's okay. It's good. It's good code. There's nothing wrong with it. But can we make it more elegant? Can we make it nicer? I mean, we do have this conditional in there, which is probably quite fragile when somebody comes along and changes the requirements a bit. It would break quite easily, I guess. And I think it doesn't really deal with all cases. It's kind of like saying, well, there's this odd case, and if there's this odd case, then we just return the vector of a string, and then for all other cases, we can do the fancy functional composition. But can we just create one expression for everything? Well, let's have a look. So what do we got? So I did try a few things. Identity, that didn't work. And then one way I found to actually find things, obviously you can go on and just do Clojure and then a word, and you can usually find something in your browser. Let's see. Oh, that's interesting. Yeah, so there's a comment saying that using 0 question mark as a function is more efficient than writing x equals x0 because it's using Java. Well, we could look at the source code. Let's look at source code. So if I want to find something, oops, that's not it. If I want to find something in Clojure, then I'll type Clojure and then 0. We'll do 0, for example. And usually we get a whole bunch of returns from Clojure docs. Clojure docs is quite nice because it's got examples in as well. And it's also got the link to the source code. So the comments from the chat is if we look at the source code, then it's doing Clojure lang numbers. Oh yeah, this is 0. So this is a Java function. You can tell it's a Java function because we've got a dot there. That's usually a good sign. Oh, and it's inlined as well. So there's some optimization there as well in terms of the compiler. So this should be a lot faster than doing that. I wonder if it's using primitive types because it's Java. It might be doing. So that makes it a little bit faster as well. There's no Java doesn't need to. The JVM doesn't need to do any unboxing, and the bytecode compiler would probably be able to optimize this away even further as well, I think. So yes. So thank you for that. That does mean that 0 is probably. Yeah, 0 is much more preferable, I think, because it's it's faster. And I think just reading it is quite nice as well. Cool. But what I did was also, where we go. If I want to find another way to find Clojure functions is just to kind of think about the words, because a lot of the functions are just English words in there. Some have very specific meanings, like map. Identities, I mean, you could say that's like an English word. We all have an identity, and apply. We're applying a function to some values as well. So there's a lot of English meaning inside there. So sometimes just extending your vocabulary a little bit, or just using the browser to help you extend the vocabulary is quite nice. So we've got so the problem we're getting with the zero length one is that we're actually returning three empty strings in a sequence, and we only actually want one empty string. So we want to find kind of the duplicates. So we've got duplicates. We want to do something about it. We've looked at flatten, but can we do something else? So what I did was search for duplicates in the browser. So I just did and the browser, and that brings up a little dictionary and some Bollywood movie, I think, as well. Excellent. I might have to watch that. And we look for similar, but there's also opposite. Opposite is to duplicate is different. What does that say? So we've got dissimilar, out of the ordinary. So we're looking for like single words that would probably be part of Clojure. Oh, and there's distinct there as well. So that gave me things to kind of go and look for. And I can go in and use something like cider apropos, and do something like distinct, and there's a couple of distincts there, and I can go and press tab and it'll show me the doc string for that as well. So it returns a lazy sequence, that's fine, of elements with duplicates removed. Excellent. That's what we're looking for. So we've got distinct. So we can just basically wrap, if we wrap distinct around what we've got already, it won't affect any of the other tests that we've got, but it will fix the zero test that we're running that's not failing at the moment. So we can simply do distinct map over that, and it's returning a single a sequence with a single empty string rather than three empty strings. I did look at, I mean, there's things like reduce conj and into, but I don't think those quite as nice as, and you still need to use distinct anyway, and you don't actually need to use the into or reduce conj around there. They don't add anything to that. Because you don't actually need to put the sequence into a vector. It's perfectly fine being a string, being a sequence, being in a list, the round brackets, because it's not the shape of the brackets that matter, it's what's inside it that counts. Possibly there's something deep and meaningful there, but essentially Clojure cares about the values, which we all should really. And so it doesn't matter if it's in a list or a vector when we're just comparing the values inside them. So I think, yeah, there's a lot playing around. So I think, yeah, this is the answer that we wanted. So basically take this into series, and we can just replace the whole of this with that. Delete that and put string. Oops, gurgle. And change that to length. There we go. Yeah, oh, that's what I've got down here, isn't it? Oh, and one, yeah, so I was fairly happy with that. Then I looked at this, I thought, well, is there something else we can do around here? I don't use it very often, but in this case, we're mapping a function over the result of partition. And we're just taking one argument in one position that's at the last position. So we can write our own anonymous function in line, and this is just the syntax shortcut for that anonymous function. But because we're only using the one argument and it's in the last place, we could actually just use partial for this, which I think is much nicer. Oh, actually, let's just get rid of this. Boom. I just do Control K, raise. I'll get rid of that. I'll just comment that out. Boom. So we've just refined the way that map is used. So partial will take this function. So we've got this function called apply string, but it's not going to call that until we actually have an argument here. This is why it's called partial, because this apply string is partially complete. It still needs an argument to make it a complete expression. And once it's a complete expression, then we can run it. So it is kind of, in a sense, it is kind of a lazy approach where we're defining an expression apply string, and it's going to take an argument just like it does here. But we don't need to define the argument or even put a placeholder in like we do with the anonymous function syntax shortcut. We can just use partial, and I think aesthetically I quite like that. Although partial is very limited. If you've got string, if you've got more than one argument, or we wanted to put the argument in a different place, then we would need to use this form, the anonymous function form. Cool. Any questions on that? Hopefully that was nice and clear. So it's a fairly simple challenge, but I thought it gives me an opportunity to explore different ways of doing it and specifically trying to create the nicest kind of code I can come up with. And you could also write this using a thread macro as well if you wanted to. I'm going to leave that for your homework. It's fairly simple. I'll put an example of that when I push this to the repository later today. But that's it. That's it for series. I think I did commit that. Oops, that's me. That's my experiments doing remote hacking. So if we go to series, then this is the one I did submit like 4 different examples until I was happy. Normally I would use join. I use Clojure string join to join things up, but I think that doesn't really add anything here. I'm not using any other strings. I'm not using the Clojure string library for anything else. But yeah, that makes sense. And using partial, I think, is quite nice. It did take me a while to understand this, but I think when you compare it with the anonymous function, I think it makes it easier to understand. So it's very much in line with, you've got a function, you can do an anonymous function, and you can do partial if you've got a much simpler case, a very specific case of you've got a function and it's only got one argument and the argument is at the end. Then you can use partial. And it's a useful function to learn. Even if you don't use it very often, it's nice to be able to kind of put it in there. It is a bit more typing, but I think it just looks a little bit nicer. It kind of reads like English, which I quite like that characteristic of Clojure as well. Okay, I'm going to wrap it up there, and I'm going to go out and do some exercise. I've been staring at the computer screen far too long this week, but I will be doing some more content over the weekend and next week as well. If you've got any feedback about what you'd like me to do, any exercises on exorcism or foreclosure you'd like me to do, then let me know. Feel free to reach out to me with any questions, preferably related to Clojure or software engineering in any of the channels. And yeah, if you've got any things you'd like to see in the books, especially around data science, it's very much for developers who are interested in doing things within the data science. I'm not going to try and teach you how to be a data scientist. There's other books to do that already. And there we go. Okay, I'm going to leave that for now. There's no more questions. So I should say thank you very much for listening, and we will see you next time. Thank you very much. Goodbye.